There are some common matrix materials which are being used these days in the market. Some are plastic, some are set, and ceramic or metals. Some are plastic, as you know very well about it, right? And it can be recycled. And some are set, it cannot be recycled, but it has excellent performance, stability. I mean, in sense of compared to the some plastic. And the ceramics, and the metal is I can skip about that here. And some of plastic matrices, it is well molded, So some of plastic matrices can be easily melted and molded into complex shapes. So as you see, it's the melting temperature is relatively low in the operating temperature viewpoints. So at most less than 300 degrees, or mostly the lower than the 200 degrees, something like that. So that means about half of melting temperature is very high operating temperature already, because from half of melting temperature in most of material started to show kind of elevated temperature or mechanical behavior. So that means in metal case we say it's creep or something like this. So it cannot be said for polymers similarly, but very similar conceptual behavior can be found. So that means the some plastic based matrix, its usable operating temperature should be lower than 100 degrees, I guess. And the some of plastic, it can be recycled. The some of plastic remelted, reused. So very environmentally friendly option can be used for that, from that. And impact resistance is a very good impact and the top property to composite. So this is very good performance we can have. But whereas the some set matrices, stability, this is the important purpose we can get from some sets, but it cannot be recycled as the weakest point. But some set compared to some plastic, we can get dimensional stability from some sets. That means its dimensional stability is resistance to deformation. It's a very the desirable performance from Somerset. So that's the reason we choose Somerset as a matrix in most times. And the adhesion property, Somerset matrix often uses strong adhesion to reinforcement materials. That means the interface can be managed tightly. It's a very good performance. And the durability issue, the Somerset composites demonstrate excellent long-term durability and resistance to environmental factors. This is superior to some of plastic matrix composite. So our matrix is the basically homogeneous material we are using, and fiber system composite is embedded inside the matrix, so it is completely continuous. So matrix surrounds fiber to protect and binding together. And fiber should carry the maximum load the matrix must provide protection. So its role is very different from fibers, not the comparable. So matrix selection should be based on chemical, thermal, electrical, flammability, environmental, cost, performance, and the manufacturing requirements. According to this kind of consideration, matrix should be chosen. And there is some matrix types: metal, ceramic, polymer. Okay, so metal matrix composite is we say MMC, and the ceramic matrix composite CMC, and the polymer matrix composite we say PMC. So each of those matrices, the disposed phase reinforcement embedded. And the matrix function is to bind and hold reinforcement together into a solid. That's the main role. And accordingly, it can offer protection to reinforcement from environmental damage. So protect the reinforcement from abrasion, okay? Because the reinforcement won't be exposed to environment by itself, and distribute the load evenly between reinforcement. Because the reinforcement should bear most of external load, but that reinforcement is discrete, not continuous together. So from reinforcement to other reinforcement, the load must be transferred through matrix. So in the sense, so it is a load distributor. And the matrix will enhance some properties of resulting material structural components. So the fiber alone cannot impart. So these properties such as transverse strength lamina, because transverse strength lamina is mainly from matrix, because in transverse over lamina there is the discrete fiber or cross sections can be shown. Impact resistance also from matrix property. So metal matrix case is a high strength, the electrical good conductor, and ductility and the toughness can be expected. The ceramic matrix case, of course, is very, very high temperature resistance performance, and its hardness and wear resistance is very, very superb. And chemical resistance also very excellent. So highly resistant to corrosion, chemical effects, something like that. So, so ceramic is ceramic. It is it's very commonly found as a grinder. That means grinder is very resistant to abrasion and wear and some kind of corrosion and the chemical environment. That means so ceramic matrix composite that manufacturing the method can be very conventional, and its performance can be easily understood. But toughness is always problem, but toughness can be obtained through the embedding the ceramic reinforcement inside. So polymer matrix, so PMC is less dense than the metal or ceramic. And PMC is can resist atmospheric and other form of corrosion, superior resistance to conduction of electrical currents. So this is some set. This one and some of plastics. This. So polymer matrix composite is a material can serve as matrix material composite. However, the matrix material are generally ceramic, metal, polymer. In reality, majority of matrix material is of course polymer. As polymer is class of natural or synthetic substances. The composite of very large molecule, which are multiples of simpler chemical units called monomers. So this is the area of chemical engineering, not to mechanical engineering. So I'm not familiar with the macromolecule is a synthesis for the method or something like that. But even though I have no the professional information or knowledge about those kind of process, but I have its performance through my mechanical model, or after the checking the output from testing. I should understand and I update my mechanical model. If I don't have any idea about basic information of the material, then it's very difficult. So I cannot neglect that kind of. How long should I wait? How long should I wait?
Now getting answer. Actually, it was on backup. Now the electricity has again.
Main power is off.
Yeah. No, main power is now it's on. Now it's on.
Now it's on.
Earlier it was on backup power.
So the academic background of this the attendees are mechanical engineering or industrial engineering? Yeah. It's various.
Most of are from mechanical engineering.
Mechanical engineering.
Yes.
The same as me.
Some of them are only from industrial engineering.
Industry. So no chemical engineering.
Chemical, no. Chemical, nobody from chemical, no? विक्रम देखेंगे
Oh.
Message. Okay.
It's angry. Huh? This computer get mad.
Now it is. Yes.
Because by my the basic the specialty is mechanical engineering. So when I was at the level of master degree, I did not understand if I study other areas the knowledge, then what those will be used. So I did not try to understand other the professional sector of knowledge, but during and after doctoral degree, I got to know without understanding the interdisciplinary the knowledge, so I cannot complete my model because I have no capability to discuss or debate the technicians engineer in that industry. In industry, so various kinds of majors are working together. So the chemical engineer and the mechanical engineer, the industrial engineer, but nobody talk only their own knowledge. They are just talking about their work. Their work is mixed together with the various the majors. So once you graduate from your department, UG, undergraduate, in the case after that, you must focus your knowledge around the product you are working on, not on your the major. So goes this kind of things. So mechanical engineer doesn't matter what kind of a form is. This is some plastic. This is some plastic, and this is some set. So after processing, the cross-linked and the no cross-link. So in mechanical engineering background, we just think everything is just continuous media, and we don't see into the nanoparticles level or molecule level. We don't mind about it. But in the case you cannot interpret your test results, and you cannot involve in industrial work. You cannot contribute your work for making money for the company. That means you cannot be promoted. You cannot be so you must change your mind from your student level to the professional level. That means everybody should be interdisciplinary engineer, not stand on only one major. So if you understand that this is the thermoplastic, this is a thermoset. Although don't know any kinds of chemical composition inside, we don't need to understand because we are not processing that material. But to understand its behavior, we need to know this kind of things. Okay? So in that case, we can understand this continuum is a three-dimensional structural stable. This is not, because this can be sliding together, so something like that. So we say this kind of, in mechanics we say micromechanics. So in micromechanics, you should build your knowledge, understanding on the basic interdisciplinary. Okay, anyway, this is a sum of plastic, sum of sets. So practically, so use some of those. Okay? And this is a group of some of plastics. So this epoxy is the favorably the used one. This is the representative matrix for PMC. Okay? So epoxy doesn't know. Why? Okay, now. So epoxy is very important to understand. So if we see a little bit more about epoxy resin, is widely used for most advanced composites. The epoxy common matrix material for high performance composite and adhesives. And the excellent combination of strength, adhesion, low shrinkage, processing possibility. So this is epoxy. It will be solidified after processing. So epoxy resin, its advantage is a low shrinkage during curing. That means low shrinkage means if you have a mold, and when it is ejected after cooling, so its final dimension can be kept as precise as you want. Although there is some shrinkage error, but compared to other polymer materials, this is advantageous in this sense. Okay, so low shrinkage, you understand in like that, and the high strength and the flexibility, you understand easily as a mechanical engineering background. Okay, so adjustable curing range, and better adhesion. Adhesion is bonding, right, between fiber matrix. Then it can grip binding tightly, so between the fiber and fiber, reinforcements, right? So this is very sticky, right? Better adhesion and the better electrical property and the resistance to chemical and the solvent. That means it can protect better the fiber reinforcements from environment, right? So this is very the positive aspect we wanted to have as a matrix. So everything has the opposite side as disadvantage. So somewhat toxic in nature, means the handling can cause some kind of hazardous environment in manufacturing field, and the limited temperature application up to 175. So that is a relatively low temperature to be used in many different kinds of working conditions. And the moisture absorption affecting dimensional property. That means it can swollen. Okay. So if you measure the dimension, then in the very humid day, high temperature, humid or low temperature, humid, or depending on the climate, the result can be different. Okay. That means you cannot use this one for precision required components. You cannot use. And high thermal coefficient in the expansion. That means if temperature changes, that means temperature of body will be influenced according to temperature level. That means the small temperature change can make large dimension change. That means in the summertime, around up to 40 degrees, and in winter time, around 0 freezing temperature. In that case, its dimension would be different. That means in whole 1 year, it's a very hot period, cold period. So if it is placed outside, that means it should suffer from summer fatigue. That means the multiple year use will not be advantageous to that part. In that case, you should not choose that kind of combination for your use. Something like that. Okay? So, so there are many things to be considered. And the curing speed is slow. That means it's the production efficiency is not high. Okay. And the common PMC fabric matrix, this is laminated. one. If you see the cross section, it's the 90-degree orientation cross section, then you see the fiber arrangement. Okay? So this is a repeated pattern you can choose. This is the minimum pattern of repetition. Right? We say this kind of repetition unit as RVE, as a representative volume element. So based on this RVE, we can calculate, hand calculate. We can calculate to get effective modulus, effective behavior of that composite substrate. So in RVE, this constituent fiber and resin matrix, or constituent alpha, constituent beta. So this is two-phase RVE. It's a simplest model of composite material. This is a simplest one. Based on that, you can calculate the maximum volume percentage of reinforcement. Okay? You cannot make, of course, 90% reinforcement volume. Okay? At most 75 to 80%, that's maximum. So, but regularly we use just 40% volume percent composite usually. So fibers, you can choose graphite, glass, Kevlar for engineering purpose. The matrix is epoxy, phenolic, polyester, and etc. Okay. So the load transfer is very important role of matrix. So load transfer means responsible for transferring load to the reinforcement. It will ensure the efficient utilization of reinforcement strength. Okay? If the load transfer is not the permitted, in the case some of a region will not work as desired as a structural performance. So, and the stress distribution. So material distribute stress throughout the composite, preventing concentration of load in single area. And the interface bonding is one of the important role of matrix to provide. And the strong interfacial bonding is needed. And it is very crucial for effective load transfer. Otherwise, if it is detached, debonded, in the case that is a defect region where load cannot be transferred. Okay? So in the sense, the adhesion performance of matrix after manufacturing is very important. And the impact resistance is important for the composite durability, so that you can get crack resistance and the environment resistance and the damage tolerance can be obtained to catch the very high resistance on the impact. In the case you will get the high impact resistant composite can be designed and manufactured. And the advance in matrix material development, nanostructured matrix, multifunctional matrix, sustainable matrix. So you can make some kind of a favorable matrix situation by mixing more. So for matrix, the wall can be enhanced. Okay? This is the case for that. And this is the example of the composite used. This is the turbo engine. So in airplane turbo engine, there's a PMC made by the so PMC make a fan blade, and the fan case also made of PMC, And CMC, ceramic matrix composite, used for combustor liner because that environment is almost 1500 degrees. So metal cannot survive this, but ceramic case it can survive up to 2300 degrees. So that's why the CNC should be chosen for extremely high temperature working condition. And another part, this is also very high exhaust gas must be expected, so CNC chosen for that. And CNC turbine vane blade shroud is used by CNC. This is one case. And the brake lining is must be very the important part for airplane safety, right? It's a nose wheel and main landing wheel. It must survive in the highly elevated temperature range. So CC composite usually used for that. And it's a friction, surface friction performance is very important for braking. So CC composite can provide those kind of properties. So not just for this kind of airplane rotor, really automotive rotor, brake rotor, also the high performance one, like a Formula One, those kind of thing, or very highly the engineered the brake system. They use CC composite for that. And high speed elevator. High speed elevator means is faster than about 700 meter per minute. In the case, those kind of elevator also use CC composite as a brake shoe. CC composite means carbon fiber, carbon matrix. And this is the bicycle, the frame. So this is a graphene reinforced metal matrix composite. It's an expensive one. It's a graphene. Actually, the difference between graphene and carbon fiber, it's the composition is exactly same, but the graphene has no cross link between layers. But, the carbon fiber has cross link between different layers, but graphene has no. So this is about matrix. Do you have any question about the matrix of composite? So, no? Yes. Thermoplastic matrix, as I said, it is more usable due to the political the policy. So, to keep eco-friendly, something like that. Recycling is enforced, right? So, some plastic can be recycled, and that kind of technique, how to disassemble and reusable, something like that, because fiber and the matrix must be they're separated. But some set case, it can keep its dimension even at moderately elevated temperature. But the thermoplastic cannot keep its shape. And it is very vulnerable to humidity. So it is inevitable to use some set matrix also. But
working temperature range, I think, is a big factor. Working temperature range of thermoplastics is very narrow.
yeah, very narrow.
That is one
Yeah,
of the
yeah.
primary reasons.
Thank you.
One more question.
Hmm?
One more question.
Okay.
Sir, asking about the photopolymers,
Hmm?
which can be printed through the DLP printer.
Mm-hmm.
And the photopolymers which are elastic in nature, means that they should be that can be used in the biomedical field.
Biomedical.
And can be photopolymerized with the help of the DLP printer. Is there some kind of this kind of application or photopolymers which are available in the market, which can be photopolymerized and used in the medical field, which have some less cytotoxicity or skin irritation?
Yeah. But compared to other engineering plastics, there are many engineering plastics already, but that material, the weakness is cost. So although it is friendly to the human health, right, because it's biocompatible. So, but if it can be replaced, can replace any other existing matrix, because its manufacturability, I mean the productivity and cost must be higher than existing ones. So it should be competing. So cost, productivity, and it's so why we have to use that the material instead of existing ones, something like this. So I cannot find the exact answer to your question, but maybe it is 3D printed.
Yes, sir.
In that case,
If you compare with the silicon,
yeah. So artificial skin, something like that.
yes, sir.
Maybe let's see that kind of things. Do you have any the desire or to use that material for something? Do you have any idea?
Yes, sir. I'm working on this.
So can I ask what is that?
Sir, biomedical application.
Biomedical
The
application.
polymerizable polymer should be elastic in nature and should be human friendly. Biological fit for the human skin.
But its strength is very low compared to others, right? Maybe I'm not sure. I think over it. I check on it. Okay. So because a few years back, one of my students, I advising one BS, the Bachelor in Science undergraduate student conducting his graduation dissertation based on those kind of materials. At the time, he was a kind of robot arm, so hand, and he attached some sensor, the pressure sensor, something like that on it. So I have one experience. He used that material, but it is too stretchable. It's very stretchable, and it is not structural integrable. Right? So there are some weakness, but interesting material. I know. I think about it. Okay? So fiber and the matrix